Hey guys, how's it going? So today we're just going to do a quick video. I know I didn't cover Qwen 3.8 27B yet, but this is the video. Basically, a disclaimer, this is one of the major models that everybody's been waiting for on release. There are two major models that Qwen has released in, the past week or something. Qwen 3.8, the 2.4 trillion parameter, 95 billion active parameter, 5 terabytes of RAM requirement at BF16, or about 512 gigabyte requirement at Q1. So yes, Q1. And that model is just massive. And I did try it at Q1 and it does work. It is pretty good. But I think the major story of which everybody else has is Qwen 3.8 27 billion parameter here. I did download, I tested basically all of the versions of Qwen 3.8, the BF16 version. I tried it on the Mac at EQ8E, it works great on the Mac. Here, you can see that I have Qwen 3.8 27 billion parameters, a chat open on the 5090, so basically a consumer card. It does have 32 gigs of VRAM. I do have some other stuff loaded on this card as well that's taking up about 8 gigabytes of VRAM, so it's not necessarily 32. You can run this exactly on a 24 gigabytes of VRAM as well, with 131 K context at Q8 on the Unsloth Q4 KXL version. And the reason I want to point out that this model is so good is, one, its score is just amazing. I believe it is tying with GLM 5.2 on artificial analysis benchmarks, but it also is very small. It is only about 17 gigabytes in size at Q4, and it can be reduced about to Q2 KXL, which is 2-bit quantization, or it's about 10 gigabytes in size, so it will fit on 12 gigabytes of VRAM really. Now, this is a dense model, so all of the model is activated at once, all 27 billion parameters of it. But what saves it is actually the speculative decoding or multi-token prediction. So it will predict 2 to 4 tokens ahead and then check all those tokens at once. If they're correct, it will basically speed up the model by about 3x, in practice 2.5 times. So while it is also running on one of the fastest bandwidth memory here on the 5090 at ridiculous speeds, I saw it can actually speed up even further if you enable something called the new D Flash 2 version that just came out. I don't know if it's completely supported here yet in Unsloth Studio, which is where we are right now, but you do have that option coming shortly, and you will be getting close to 200 and something tokens per second on decode. Now, that is one of the things that I was really concerned about, is the throughput of this model. And the reason is because this model, as you can see, thinks a lot. It's 73,000 tokens out of 131 used right there. And what I've been seeing recently is these models have becoming much better. And while we're doing this, I will show you the Acropolis here that this model has generated. Let's just do flyover and a bit of a better time of day here. And so this model has basically generated this Acropolis scene all in JS, JavaScript, HTML. And honestly, recently, this has not been possible with local AI models. And even with the DeepSeek V4 Flash, it does struggle quite a bit to get to this point. And of course, this is not on the level of the 2.4 trillion parameter models that have really great gradient, more detail, and can actually see the scene in more detail and thus producing a better visual quality. But this is like 95%, 90% of that scene. And the thing about the 90% is this is running on one graphics card at about 108 tokens per second. It does chew through like the 60k tokens like pretty instantly and does like retry tools like very, very fast. So I will say like this is very good. If I was waiting for like an hour in the past and like about an hour and a half these days for the very slow GLMs or local models to pump out this kind of quality on one shot, this model can go through, agentically correct itself, verify loops, and read all of that all through the Unsloth Studio here. As you can see, it's basically doing a bunch of tool calls right in the chat window in Unsloth Studio to verify how the scene has come out and correct anything that's required. So really, what I have to say about this is, one, the quantization of these models has become less and less an issue, because in the past, if you were to basically ask it to generate some sort of artifact, or let's say output here, the first issue you would get is one, quantization errors, which means if you compress a model from, let's say, floating point 16 or 32 all the way down to Q4 or quantization 4, where you're cutting off a lot of these floating point numbers to 4 digits. I know it's not exactly how that works, but an example that's you're going to be losing quite a bit of quality. And what that means is the model will start to make errors about 1 in every 256 lines, 1 in every 64, etc. And you will get the wrong token for that output. Now, where that becomes a problem is once you start, the model starts looping and becoming non-coherent. And you might get, the roof on this Acropolis completely messed up or in a different position with the quantized version versus the unquantized version. But what these agentic frameworks fix is the ability for the model to go in after the fact and correct itself and still get a great result after noticing its 3 errors. All right, so now that is basically saying that quantization plays a part in, you use more tokens to get out the same output versus the original, 56 gigabyte version in this case model. Whereas this one is 17, you can cut it down to 10, etc. So now we have an issue with how much space we can allocate actually to the context, which is 131K here on the 5090, because I don't have enough VRAM. And if I spill into the RAM, I get a completely different experience where it's very slow. Now, 131K is very, very usable, I would say. And, you can get to 266 here, and it wouldn't be crazy to actually use the 266K context all in one go, because this model just eats tool calls. For example, here. Now, let me show you one of the outputs that I requested, and I saw on Reddit that, this was one of the, SVGs that people are making, which was to create a horse on a blue bicycle, misspelled bicycle, in the desert with a camel in the background. Now, it goes ahead and kind of generates this output here on the 5090 at 100 tokens per second, which was pretty quick. And then 106, that took about yeah, prompt processing was also insane. It took a bit of time. Let's say then I asked it to go ahead and improve it again. And these loops and iteration loops happen quite fast on the 27 billion parameter model. So I'm actually not concerned about this at all, just because of the speed. And you would probably be getting like around 60 on like the 3090, because the limit on this is basically your bandwidth, memory bandwidth. All right, so let's just go ahead. And so I said, okay, go ahead and improve it. And so what it does is it then reads the file, and then it checks all the coordinates. It uses Python to check the coordinates here and says, yes, those are okay, or we can update it a bit. And then it says, okay, what are the colors? So instead of actually using vision, it uses something where it imports the PNG, and then it breaks it out into a color table here. This is the output how it sees. And then it decides based on that to make changes. And so this is the version that it came out with. So the camel there is right behind my head, but regardless, you have like a horse on a bike, and you have a sun, cactus. The point I'm trying to make here is not necessarily like the quality and art style of this model, because obviously it's going to get better over time, but it's not making like large errors. It's not making like complete garbage outputs like most of the large models, even ChatGPT 5.5, 5.4 were making. This is very coherent. This does look like what it says it does, which is a horse on a bike in a desert. Now, where would I be in this video if I didn't finalize with referencing the artificial analysis index? So we have a reference point here. We have the Qwen 3.8 here. I'm just going to go ahead and highlight it at 52 on the artificial analysis index, which doesn't mean anything. That number doesn't mean anything in regards to everything, because the benchmark score changes all the time from v4.1 right now 0.1 to maybe the next iteration it will jump, but in relation to everything else it does make sense. So if you were to go with Qwen 3.8 27B X high, you can see that the score does drop significantly to medium, and then not that much to low. So if you're going to be using it, it's basically, there's two options. Either use the X high version or use the low version, right? So the medium it's going to use token, but whatever. And that's still better than Qwen 3.6 27B, like altogether. So then I want to show you guys that we're also basically competing here with Luna, GPT 5.6 Luna, which is the cheapest version that ChatGPT has, and DeepSeek V4 Pro Max here. Like, we are competing with like very large models. We're only a couple points away also from like basically the very frontier. Now, these 8 points is actually quite a lot if you were to compare like Kimi K3 to Qwen 3.8 27B, but really not that much, because we just went from Qwen 3.6 27B 38 to like a 52. And so the next jump is also going to be massive, guys. It is going to be just an amazing, year for everybody. And I think, what are you going to be using in your scenarios?